morning everyone. Welcome to the online CET NEET JEE classes. Students, in this video I am going to discuss one more important your first PUC chapter, that is chemical bonding, with some multiple choice questions. Students, chemical bonding, it is also very important for your CET and NEET level examination. So in this chapter, first we concentrate on the main points like what is chemical bonding, what is the difference between ionic and covalent bonding, and understand clearly the concept of chemical bonds by relating it to the everyday life, and how to draw the Levi structures showing different type of bonds, all the types of bonds, the various properties of ionic and covalent compounds, and different diagrammatic representation of bonds by using VSEPR theory, molecular orbital theory, as well as valence bond theory. Students, please observe the synopsis points. See here, what is chemical bond, how we understand this. Students, we know about marriage. Marriage means it's like a forming a bond, as during marriage time we are more stable and exothermic. But during the divorce means the breaking of a bond. Divorce means it shows the breaking of a bond. During this time we are less stable and become endothermic. Is it right? Yes. Students, in the chemical bonding chapter, first we concentrate on the concept of valence electrons. Valence electrons. What are valence electrons, students? This is the basic point. The electrons that are in the higher energy level. Yes, we know in the theory classes how you define the valence electrons. Valence electrons, these are the electrons present in valence cell. The electrons present in the outermost cell. ಹೊರ ಕವಚದಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿಗೆ ನಾವು ಏನಂತಿದ್ದೇವೆ, ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಅಂತ ಕರೀತಾ ಇದ್ದೇವೆ. ರಿಮೆಂಬರ್, the electrons means valence electrons where it is present in the last cell. That last cell is called as valence cell. The electrons present in that valence cell are called valence electrons. So I given the point, this level means the valence electrons are present in that cell, that is valence cell of an atom. They are held most loosely. The number of valence electrons in an atom, it determines the properties of the atom. The number of valence electrons in an atom determines the properties of atom. Students, carefully observe this table. Here I given group and group name and number of valence electrons in a particular group. We know group 1 elements are called as alkali metals, and in presence of alkali metals the number of valence electron is 1. If you take an example, sodium, it is an example for alkali metal and its atomic number is 11, but it contains only 1 valence electron. Similarly, in group 2, alkaline or metals, it contains 2 valence electron. Transition metals contain 1 or 2. Boron group contain 3. Carbon group means 14th group elements are contain 4 valence electron. 15th group 5 electron. Oxygen group 6 valence electrons. We know halogens means 17th group elements contain 7 valence electrons, 18th group elements contain 8 valence electrons. Next, another concept, octet rule. Octet rule. What is octet rule? ಇದಕ್ಕೆ ನಾವು ಕನ್ನಡದಲ್ಲಿ ಅಷ್ಟಕ ನಿಯಮ ಅಂತ ಕರೀತಾ ಇದ್ವಿ. What is octet rule? The octet rule is a simple chemical rule of thumb. This octet rule says atoms with 8 electrons in their outer shell are stable. According to this octet rule, atoms with 8 electrons, means octet configuration, in their valence shell are most stable. Students, remember, Causal and Lewis usually developed the valence theory of chemicals bonding to explain the formation of chemical bond. According to this theory, every atom, it always tries to get the octet configuration in its valence shell either by gaining, losing or sharing of electrons. This is called octet rule. Once again, see this point. According to Lewis causal theory concept, every atom tried to get octet configuration in its valence shell by gaining, losing or sharing of electrons. This is called as octet rule. The rule applies to main group elements, especially carbon, nitrogen, oxygen, halogens, and also to the metals such as sodium or magnesium. Students, when you observe the limitations of this octet rule, some points are observed. This octet rule, it does not allow for hydrogen, helium or lithium. Octet means contain 8 electrons in the outermost shell. Those 8 electrons become either by sharing or gaining of electron. This octet rule, it does not applicable for transition elements because they contain 18 electron rule. Boron trifluoride, which has only 6 electrons in its outer shell. Therefore, this octet rule is not applied to the molecule of boron trifluoride. Students, in the theory class, we already know what is bond order, how to calculate this. See once again the point, bond order. What is bond order, students? What is bond order? Bond order, it is the number which shows the bonds present between the two atoms. What is bond order, students? Bond order, it is nothing but the bond number present between two atoms. Yes. What is bond order, students? It is the number of bonds formed between the two atoms, and it is calculated by using the formula bond order equal to NB minus NA divided by 2. This formula is already known in our theory classes. What is the formula? Bond order equal to NB minus NA divided by 2. What is that NB? Number of bonding electrons. And when you observe different type of books, there is a different formula for bond order. Bond order equal to number of electrons in BMO, means bonding molecular orbitals, minus number of electrons in ABMO, means anti-bonding molecular orbitals, divided by 2. Yes, when you observe the one example, this one is acrylonitrile. acrylonitrile. The structure of the compound is CH2, double bond CH, single bond C, triple bond N, acrylonitrile. Yes, when you observe this structure between these two carbon atoms, there is a double bond, as here there is a single bond and here there is a triple bond. So bond order, it shows the number of bonds present between two atoms. Here triple bond, single bond, double bond, etc. Is it right? As I already given the formula, this is also another type of formula. You use any one formula. Yes, next students, now my main concept, that is what is chemical bond. I think already you know the definition point in your theory classes. What is chemical bonding? Students, remember, it is the attractive force which holds the ions, atoms or molecules together in a substance. What is chemical bonding or chemical bond? It is the attractive force which holds the ions, atoms or molecules together in a substance. Students, we know compounds are formed from chemically bound atoms or ions. Bonding involves only the valence electrons. We know only valence electrons involved in the bond formation. And this chemical bond is formed by the electrostatic force of attraction between two opposite charges, either between electron and nuclei. As remember the definition point of chemical bond, it is nothing but the attractive force which holds the ions, atoms together. Students, remember one very important point. Linus Pauling, a famous scientist and winner of 2 Nobel Prizes, he developed innovative techniques to investigate the chemical bonding and molecular structure. He won his first Nobel Prize for his investigation of genetic chemistry and the second for his dedicated efforts to stop nuclear weapons testing. Remember the name of the scientist who studied more on the chemical bonding and molecular structure and got Nobel Prize, Linus Pauling. Why are chemical bonds formed? Why chemical bonds are formed, students? Students, chemical bond is formed due to the electrostatic force of attraction between two opposite charges. We know this point. Why do atoms bond together? Why the atoms are bound together? Atoms bond together because to attain a stability. To attain a stability, the atoms are bound together, and to complete the octet configuration, because in the octet configuration they become more stable, as therefore to complete the octet configuration the atoms are bound together. And for the formation of molecules the atoms are bound together, and to achieve the noble gas configuration they bond together. If they ask the question why the atoms are bound together, you know at least 1 or 2 points. Yes, students, next another concept, Levi's dot structures. I think you know what are Levi's dot structures. The outermost electrons means valence electrons present in an atom can be represented by dots. It's called Levi's symbols or dot structures. ಒಂದು ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಅಂತ ನಾವೇನು ಕರಿತೇವೆ, ಅವುಗಳನ್ನ ಏನ್ ಮಾಡ್ತೇವೆ, ಆಟಮ್ ಸುತ್ತ ಚುಕ್ಕೆಗಳನ್ನ ಇಟ್ಟು ಅಥವಾ ಡಾಟ್ ಗಳನ್ನ ಇಟ್ಟು ಚಿತ್ರಿಸುವಂತಹ ಒಂದು ವಿಧಾನ ಇದು. Remember students, sum of the valence electrons from all atoms add number 1 for each negative charge and subtract 1 for each positive charge, because we know, students, if I write positive charge on the atom, it indicates loss of an electron, and if I write minus charge on an atom, it indicates the gaining of one electron. Is it right? Yes. When you observe this example, here I write Na dot changes to Na plus, means it already lost one electron. Mg2 plus, these 2 electrons are lost here, and O2 minus, 2 electrons are lost. Students, drawing the Levi structures. While drawing the Levi structures, first you draw a skeleton structure with atoms attached by a single bonds. Now ಏನು ಮಾಡಬೇಕು? ಫಸ್ಟ್ ಲೆವಿ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನು ಬರೀಬೇಕಾದ್ರೆ ಆ ಒಂದು ಆಟಮ್ಸ್ ಗಳಿರ್ತಕ್ಕಂತ ಸ್ಕೆಲಿಟನ್ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಸಿಂಗಲ್ ಬಾಂಡ್ ಹಾಕಿ ಬರ್ಕೊಳ್ಳೋದು. ನೆಕ್ಸ್ಟ್, ಕಂಪ್ಲೀಟ್ ದ ಆಕ್ಟೇಟ್ಸ್ ಆಫ್ ಆಟಮ್ಸ್ ಬೌಂಡ್ ಟು ದ ಸೆಂಟ್ರಲ್ ಆಟಮ್. Place extra electrons on the central atom. If the central atom does not have an octet, try forming multiple bonds. Yes. Carefully observe the steps used while writing the Levi dot structures. Yes, you remember the point. What are Levi symbols or structures, students? Levi symbols are the valence electrons or dots arranged around the atomic symbol. If you take an example H, it contains one electron, therefore I write one dot on the hydrogen. And sodium, it contains one valence electron, therefore I write here also one dot. Chlorine, S, here I write Cl with 7 electron, because chlorine, it contains 7 valence electron. If I write Cl minus, then one more electron is added here. Students, next very important concept, that is ionic bonding. Yes, what is ionic bonding, students? The chemical bond formed by the transfer of electrons from one atom to another is known as electrovalent or ionic bond. Remember, ionic bond is also called as electrovalent bond. Simply we define this point: the complete transfer of one or more electrons from outermost cell of an atom. Complete transfer of one or more electrons from outermost cell of an atom. Simply transfer of electrons from one atom to another atom. It's nothing but ionic bonding. If you take an example, NaCl, sodium chloride, potassium chloride, magnesium chloride, etc. Students, when this ionic bond is formed, remember, ionic bond is formed when a cation, means the positive ion, it transfer the electrons to other anion, means negative charge containing ion. You see here one cation is present, it contains positive charge, means it indicates loss of electron. Neutral atom here, and it becomes gain of electron. By gaining of electron, it becomes an ion. Here sodium chloride, I take one example. Here it contains, means sodium, it contains one valence electron, therefore it is electropositive because it lost one electron. And Cl, it contains 7 valence electrons. By gaining of one electron, it becomes, or it shows, octet configuration. Therefore between NaCl, it contains ionic bond. Therefore NaCl, means sodium chloride, is an example for ionic bond. Some characteristics of ionic bonds, very important, students. Metal atoms always lose their valence electron to form a positive ion or cation. I think you also know this point. Metals are always give the electrons to other and having positive charge. If you take an example, Mg, I write +2, Na +1, because the metal atoms always give the electron. Non-metal atoms always gains electrons to form negative ions. If you take an example, Cl, we write minus charge on the Cl because it is one of the non-metal and it always gains electrons to form a negative ion. Thus, ionic bonds result from the attraction between the opposite charged ions. Students, remember, ionic bond, it forms the attraction between the oppositely charged ion because the bond present between one positive ion, one positive charge and negative charge. Here sodium atom and chlorine atom, we know how the bond is formed. Here sodium atom, it lost one electron, and chlorine atom, it gains one electron. Then only the sodium chloride contains ionic bond. Properties of ionic compounds. Students, in the theory class we discussed some points related to some properties of ionic ionic compounds. Ionic compounds present in solids and liquids. These are soluble in water but insoluble in organic solvents, and ionic compounds are good conductors of electricity. They have high melting point and boiling point, and also the ionic compounds are good insulators. Remember, ionic compounds are good insulators. Let's see here some points given. Physical nature of ionic compounds. Solids which are in the form of crystals and relatively hard because of strong electrostatic force of attraction. Students, remember melting point and boiling point. As the ions in the ionic compounds are closely held together by strong intermolecular attraction, the solid ionic compounds are generally crystalline. A considerable energy is required to break the close packed crystalline structure, hence both melting point and boiling points are high. Remember, ionic compounds contain high melting and boiling point. And we know solubility concept of ionic compounds. Ionic compounds are generally soluble in polar solvents like water and insoluble in non-polar solvents or less polar solvents like alcohol, ether, benzene, etc. I know. Sodium chloride, it is soluble in water. Yes. Next, another concept, students, Born-Haber's cycle. Students, Born-Haber cycle usually is to explain the formation of sodium chloride along with the lattice energy by sodium and chlorine molecule. Born-Haber cycle, it explains the formation of sodium chloride along with the lattice energy by sodium and chlorine molecule. Students, I think we also know Born-Haber cycle, it involves 5 steps. In that first step, formation of sodium chloride. Here we take Na plus Cl2 gives NaCl. But here I give a flow chart. Here I take M and X2. Here M is one of the metal and X2 is one of the halogen. In the theory class, by using sodium chloride, I take this concept. Okay, is in the first step formation of sodium chloride. In second step, sublimation of solid sodium metal. In third step, dissociation of Cl2 molecule to chlorine atom. And in the fourth step, I take ionization of sodium atom to its ion form. And in the last step, addition of electron to chlorine molecule to form a chloride ion. As this thermochemical cycle was devised by Born-Haber in 1919, it relates the lattice energy of a crystalline substance to other thermochemical data. Remember students, the Born-Haber cycle is applications of Hess law to the enthalpy of formation of ionic solid at 298 Kelvin temperature. Students, next another point, another different type of chemical bond, that is covalent bond. When we come to the point of covalent bond, we remember one definition point: the bond formed due to the mutual sharing of electrons. Remember, the bond formed due to the mutual sharing of pair of electrons in between two similar or different atoms are called as covalent bond. Students, remember, covalent bond is formed due to the sharing of electrons between two atoms in such a way that each atom in the resulting molecules gets the stable electron arrangement of inert gas. This is covalent bond. Chlorine molecule, it contains covalent bond because the mutual sharing of electron takes place between two chloride atoms. HCl, CH4 means methane, carbon dioxide, nitrogen molecule contain covalent bond. Covalent bond is formed between two non-metals. This is very important point, students. Covalent bond is formed between two non-metals. As I take example water here, we know molecular formula of water is H2O, two hydrogen atoms bind with one oxygen atom, and here oxygen molecule, two oxygen atoms, and methane. These are some examples which contain covalent bond. Students, remember, there are some types of covalent bonds. Usually there are three types of covalent bonds. In that, first one is single covalent bond, means it contains single bond. Single covalent bond, where it is present between chlorine molecule, hydrogen molecule, methane, HCl, NH3. It contains single covalent bond because between the atoms there is a single bond is present. And double covalent bond, when you observe the structure of CO2, O2, C2H4, etc., it contains double covalent bond because between the atoms there is a double bond. And triple covalent bond, N2, C2, H2, due to the triple bond present between two nitrogen atoms. It is an example for triple covalent bond containing molecule. Students, depends on the mutual sharing of electrons. The bonds are formed between two atoms. Examples for covalent bond. Some examples are given here. Go through the chart here. First one, two hydrogen atoms both contain one electron, and due to the mutual sharing of electron, hydrogen molecule is formed with the single covalent bond. Between chlorine atom, it contains single covalent bond. Hydrogen and Cl means chlorine chloride atom. Here it contains HCl. Between H and Cl, it also contains a single covalent bond. Now we observe formation of a single covalent bond in Cl2. How the single covalent bond is formed between two chlorine atoms, two Cl atoms. Students, remember, a single covalent bond is formed by the sharing of only one pair of electrons between two atoms. ಎರಡು ಆಟಮ್ಗಳ ಮಧ್ಯೆ ಒಂದು ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾರ ತಮ್ಮ ಒಳಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಶೇರ್ ಮಾಡ್ಕೊಂಡಿತ್ತು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಸಿಂಗಲ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಕಂಡು ಬರ್ತಿರ್ತಾರೆ. See here, Cl has electronic configuration of 287. These are electrons. 1s2, and it means 287. It indicates in the first cell it contains 2 electrons, and in second cell it contains 8 electrons, and in third cell it contains 7 electrons. Right? Therefore, it contains 7 valence electrons. In the valence cell Cl, it contains 7 electrons. Then to attain a octet configuration, it need only 1 electron. ಈಗ 7 electrons valence cell ನಾಗ ಅದಾವ ಅಂತಂದ್ರೆ 8 ಆಗಕ 1 electron ಬೇಕಾಗಿದೆ. ಇದಕ್ಕ to achieve the 8 electron inert gas configuration. Thus both the Cl atoms will become stable by sharing 1 electron with each other. ಏನ್ 7 ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ದು ಅದ್ರೊಳಗೆ ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತದ ತಮ್ಮೊಳಗ ಶೇರ್ ಮಾಡ್ಕೊಳ್ತದ. Covalent bond has formed a chlorine molecule. Structural formula Cl, single bond Cl, molecular formula Cl2. Right? As students, similarly formation of double covalent bond. Double covalent bond present in CO2. Therefore, I take one example. A double covalent bond is formed by the sharing of 2 pair of electrons between 2 atoms. 1 pair electron share ಆಗಿತ್ತಂದ್ರೆ ಸಿಂಗಲ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗ್ಯದ ಅಂತ ಹೇಳ್ತಿದ್ರಿ. ಅದೇ ತರ 2 ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾದ್ರೂ ತಮ್ಮೊಳಗೆ ಶೇರ್ ಆಗಿ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗಿದ್ರೆ ಅಲ್ಲಿ ಡಬಲ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಕಂಡು ಬರ್ತದೆ. Here I take CO2 an example. Carbon has electronic configuration of 2,4 because its atomic number is 6. In the first cell it contains 2 electrons. In the second cell it contains 4 electrons. Therefore it has 4 valence electrons. So it needs 4 more electrons. 4 valence electron ಅದಾವ ಅಂತಂದ್ರೆ octet configuration ಪಡ್ಕೊಳ್ಳಾಕ ಇದಕ್ಕೆ ಇನ್ನು 4 ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ಅವಶ್ಯಕತೆ ಅದ. To achieve the 8 electronic configuration, it need 4 more electrons. Oxygen has less electronic configuration. Oxygen has electronic configuration of 2,6. In the first cell it contains 2 electrons. In next cell it contains 6 electrons. Therefore, it contains 6 valence electrons. So it needs only 2 more electrons to achieve the octet configuration. So 2 oxygen atoms combine together with carbon by sharing 2 electrons each to form a molecule of CO2. See the structure carefully. Here I wrote the structure of CO2 here, and here combination of CO2 molecule. Similarly, formation of triple covalent bond in nitrogen molecule. Triple covalent bond is formed by sharing of 3 pairs of electrons between 2 atoms. A triple covalent bond is formed by sharing of 3 pairs of electrons between 2 atoms. Students, we know if 2 pair of electrons involved in the mutual sharing, then a double covalent bond is formed. If 3 pairs of electrons involved in the sharing, then the triple covalent bond is formed. If you take an example, the electronic configuration of nitrogen is 2,5 because its atomic number is 7. It contains 5 valence electrons, so it needs only 3 more electrons to achieve the octet configuration. And 2 nitrogen atoms combine together by sharing 3 electrons to each to form a molecule of nitrogen gas. ಈ ಒಂದು ನೈಟ್ರೋಜನ್ 7 ಅಟಾಮಿಕ್ ನಂಬರ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಅದ್ರ ಒಳಗ 5 ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವ. ಆ 5 ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದೊಳಗ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಂದು ನೈಟ್ರೋಜನ್ ದಾಗಿರ್ತಕ್ಕಂಥ 3 ಮತ್ತೊಂದು ನೈಟ್ರೋಜನ್ ದಾಗಿರ್ತಕ್ಕಂಥ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತಮ್ಮೊಳಗ ಪರಸ್ಪರ ಹೊಂದಾಣಿಕೆ ಮಾಡ್ಕೊಂಡು ಏನ್ ಮಾಡ್ತಾವ, ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಕೊಟ್ಟು ನೈಟ್ರೋಜನ್ ಅಂದ್ರೆ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಮಾಡ್ಕೊಂಡು ನೈಟ್ರೋಜನ್ ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡ್ತದ. Next, another concept, that is properties of covalent compounds. Students, in the theory class we know some points related to these properties of covalent compounds. In that, first one, covalent bond compounds can exist in 3 states: solids, liquids, as well as in gaseous states. covalent compounds are mainly present in molecules. Remember, this is very important point. Covalent compounds mainly contain molecules. Covalent compounds are soluble in organic solvents but not in polar solvents like water. These covalent compounds are bad conductors of electricity. These compounds have low melting point than ionic compounds. As here also I take some points related to the properties of covalent compounds, like physical state can exist in solids, liquids as well as gaseous states. When we compare the melting point and boiling point of these covalent compounds, they are less than ionic compounds. And electrical conductivity of covalent compounds is poor conductors of electricity because they neither contain the ions nor the free electron to necessary for conduction. Next, another point, students, dipole moment. Dipole moment. What is dipole moment? Yes, how you define the term dipole moment, students? We know the product of electric charge and the distance between the opposite charges in a polar molecule is known as dipole moment. Remember the definition point. What is dipole moment, students? It is the product of electric charge and the distance between the opposite charges in the polar molecules is known as dipole moment. We know the dipole moment is indicated by the symbol mu, and mathematical expression is given for dipole moment is mu equal to E into D, where E is electric charge and D is the distance between the opposite charges, and its unit is dBA. It is measured in dBA, and the value of 1 dBA equal to 3.3356 into 10 to the power of minus 30 coulomb meter, or 1 into 10 to the power of 10 ESUA. Okay, students. Next, another important concept, VSEPR theory. What is VSEPR theory? Valence electron pair repulsion theory. Remember, this theory is proposed by famous scientists Sedgwick and Powell in 1940 to explain the shape of a covalent molecules. Remember, usually VSEPR theory means valence shell electron pair repulsion theory. It is the model for understanding and predicting the shape of a molecule. Usually this theory is based on the principle that electron will spread out as far as possible from each other as a result of their mutual repulsion. When you observe the postulates of this VSEPR theory, already we learnt some points. In that, if I take some points, first one is shape of the molecule depends upon the number of valence shell electron pairs around the central atom. Valence shell electron pair repel one another because they are negatively charged. To overcome this repulsion, the electron pairs arrange themselves in a space and come away from one another. One point to remember in presence of postulates of VSEPR theory, students, the repulsive forces between the electron pairs decreases in the order of lone pair. Repulsion is more in presence of lone pair electrons is greater than lone pair bond pair electron than bond pair electron. In presence of lone pair of electrons, it causes distortion due to the repulsive force in the geometry of the molecule. Remember, in presence of lone pair of electrons, distortion is observed in the geometry of the molecule. If you observe the structure of If you observe the structure of some given examples here, in this first one it is tetrahedral structure. Take an example CH4. It contains tetrahedral structure. As students, next one trigonal pyramidal. If you take an example NS3, it contains two pair of electrons. Here two electrons are present. Due to the lone pair of these electrons, the geometry of the molecule undergoes distortion. Therefore, bond angle decreases when you compare with the tetrahedral structure. Next, when you observe the structure of water molecule, it has bench structure. It contains two pair of electrons. Therefore, the geometry of the molecule is undergo more distortion than ammonia. Next, valence bond theory, or also called as orbital overlap theory. Students, remember Linus Pauling, he introduced one of the most beautiful theory, that is valence bond theory. There are different types of overlapping. One is SS overlapping, PP overlapping, SP overlapping, etc. In presence of SS overlapping, half-filled s orbitals of two combining atoms overlap each other. This is known as SS overlapping, and it is shown in the diagram. Here one s orbital, another s orbital combine to form SS overlapping, and one of the s orbital and one p orbital combine to form or shows sp overlapping, and p orbitals combine to form or shows pp overlapping. When you observe the postulates of valence bond theory, some very important points are observed. Like, a covalent bond is formed by overlapping of orbitals having unpaired electrons. Students, remember this point. A covalent bond is formed by overlapping of orbitals having unpaired electrons. The covalent bond formed is stronger when the overlapping between the orbitals is greater. When the covalent bond is formed, it becomes stronger when the overlapping between the orbitals is greater. When the covalent bond is formed, the energy of the molecule becomes less. Remember, this is also very important. When the covalent bond is formed, the energy of the molecule becomes less. The overlapping along the axis means the formation of sigma bond is more stronger than overlapping along the sideways, means formation of pi bond. Another type of overlapping, that is pp sideways overlapping, means pi bond formation, is shown in the diagram. Next, types of covalent bonds. I think we know one, how the sigma bond is formed and how the pi bond is formed. Sigma bond means the bond formed due to the axial overlapping, and pi bond means bond formed due to the sideways overlapping. When you observe the differences between the sigma and pi bond, some points already given here. You know, sigma bond is formed due to the axial overlapping, and pi bond is formed due to the sideways overlapping. Sigma bond, there can be only one sigma bond between the atoms. There can be more than one pi bond between the two atoms. The electron density is maximum and cylindrically symmetrical about the bond axis. The electron density is high along a direction. The bonding is relatively strong, means sigma bond is strong bond and pi bond is one of the weak bond. Pre-rotation of atoms around the sigma bond is possible. Pre-rotation about the pi bond is not possible. It can be formed independently, but pi bond is formed always with sigma bond. Next, another type of bond, students, that is coordinate bond. Coordinate bond. What is coordinate bond, students? Remember, this coordinate bond is also called as dative bond. Dative bond. It is the covalent bond where the shared pair of electrons are contributed or denoted by one of the bounded atom is known as coordinate bond. Remember or observe carefully this point. Dative bond, it is also a covalent bond where the shared pair of electrons are donated by one of the other bounded atom is known as coordinate bond. Students, see here, in a simple covalent bond, each atom supplies one electron to the bond, but that does not have to be the case. A coordinate bond is a covalent bond in which both electrons come from same atom. When you observe the example of ammonium ion, formation of ammonium ion, here NS3, it is electron donor and H plus acceptor. As here NS3 and H plus, it forms ammonium ion NH4 plus. Right, as between the bonds present between the N and H means nitrogen and hydrogen atom, one of the bond, it is coordinate or dative bond. Students, next another very important theory, that is molecular orbital theory. Molecular orbital theory. What is molecular orbital theory? Molecular orbital theory, it is proposed or explained by another famous scientist, R.S. Mulliken, to explain the nature of bonding in. This molecular theory is given by scientist Mulliken and awarded Nobel Prize for Chemistry in 1966. When you observe the postulates of this theory, students, remember this theory usually explains the combination of molecular orbitals. When the atomic orbitals are combined, they form molecular orbitals. According to molecular orbital theory, when the atomic orbitals are combined, they form molecular orbitals. Atoms are combined to form molecules. Similarly, atomic orbitals are combined to form a molecular orbitals. These molecular orbitals are polycentric. Is it right? Yes. They are polycentric. Molecular orbitals is three-dimensional region around the nucleus where the probability of finding the electron is more in a molecule. Students, remember, according to molecular orbital theory, when two atomic orbitals are combined, they form molecular orbitals. In that there are two types. One is bonding molecular orbital, simply written as BMO, and another one anti-bonding molecular orbital, that is ABMO. This BMO means bonding molecular orbital has lower energy, and ABMO means anti-bonding molecular orbital has higher energy. Bonding molecular orbital is represented by sigma or pi, and anti-bonding molecular orbital is represented by sigma star and pi star. Each molecular orbital filled with the maximum of 2 electrons with opposite spin. Yes, these are some postulates. Please go through your notes and observe all the points, because this molecular orbital theory is very important for your future. Yes, students, the energy level diagrams for this molecular orbital theory is given here. For the molecules like boron, carbon, nitrogen, means the atomic number less than 7, we use the first graph. This is the energy level diagram for the molecules having atomic number less than 7. Here sigma, sigma star, pi, sigma, This represents the BMO as well as ABMO, bonding molecular orbitals as well as anti-bonding molecular orbitals. As this diagram, this is another type of energy level. This is used for the molecules which having the atomic number greater than 8 or greater than 8. If you take an example, dicarbon, carbon atomic number is 6. Here dicarbon means 12 electrons involved in the BMO as well as ABMO. And here dioxygen, we know in the theory classes, oxygen molecule, it is paramagnetic in nature because it contains 2 unpaired electrons and bond order is 2. It is calculated by using formula bond order equal to Nb minus Na divided by 2. Here we know BMO means bonding molecular orbitals and ABMO means anti-bonding molecular orbitals. Bonding molecular orbitals are represented by sigma and pi, but anti-bonding molecular orbitals are represented by sigma star and pi star. When you observe these diagrams, some they are represented by sigma and pi, some orbitals are represented by sigma star and pi star. These stars represent anti-bonding molecular orbital electrons. Yes, next another very important point, students, it is about hydrogen bonding. Students, what is hydrogen bond? First question. Remember, the bond formed between hydrogen atom of one molecule with more electronegative atom of another molecule or same molecule is known as hydrogen bond. If you take an example, HF, H2O means hydrogen chloride, water molecule, ammonia, all these contain hydrogen bonding because it contain one hydrogen and electronegative atom. Between these atoms there is a bond that is called hydrogen bond. Students, when you observe the structure of H2O molecule, means water, here one of the hydrogen it binded with oxygen and that oxygen is binded with another hydrogen. Yes, it is one molecule, and another water molecule here. One of the hydrogen it is also bonded with oxygen and another oxygen is again attached to the same oxygen atom. Here hydrogen atom of one water molecule and electronegative atom of another molecule hold by one electrostatic attraction or the bond that is called hydrogen bonding. Similarly, in H2O means solid state of ice, the hydrogen bond is present. Students, the positive charge on the hydrogen can exert electrostatic attraction on the negative charged electronegative atom of same or other molecule during hydrogen bond formation. Is it right? Yes. Remember, the bond between the hydrogen atom of one molecule and a more electronegative atom of same or another molecule is called hydrogen bond. There are two types of hydrogen bonding, students. One is intermolecular hydrogen bond and another one intramolecular hydrogen bond. First I take intermolecular hydrogen bonding. Remember, intermolecular hydrogen bonding, when the hydrogen bonding is between the hydrogen atom of one molecule and an atom of electronegative atom of another molecule, it is termed as intermolecular hydrogen bonding. Simply, the bond formed between two different molecules of same or different compounds is known as intermolecular hydrogen bonding. If you take an example, hydrogen fluoride molecules, not an atom, hydrogen fluoride molecules, HF, HF, HF. If you write the molecules in a linear structure, when you observe first one and second one, the hydrogen atom present in first one and electronegative atom of second one, they bind with bond, that is called hydrogen bonding. Especially here it is intermolecular hydrogen bonding. When the hydrogen bonding is present between hydrogen atom of one molecule and electronegative element of another molecule, it is termed as intermolecular hydrogen bonding. Next, another one type, students, intramolecular hydrogen bonding. Intra means within themselves. Intramolecular hydrogen bonding means the bond formed between hydrogen and electronegative element or atom within the same molecule. The intramolecular hydrogen bonding is formed between the hydrogen atom of one group and the electronegative atom of adjacent group in the same molecule. Some examples are taken here. One is orthonitrophenol. Observe the structure carefully. Here the oxygen atom and hydrogen atom, they contain force of attraction, and it is also called as hydrogen bonding. Especially here the bond present between the atoms within the molecule, right? Therefore it is an example for intramolecular hydrogen bonding. Another example, if you take an example, salicylaldehyde, orthonitrobenzoic acid, they contain intramolecular hydrogen bonding. Students, these are the some synopsis points very helpful for your CET as well as NEET level examinations on the chapter chemical bonding. Along with, I left another concept, that is Fuzzen's rule, and another one formal charge concept, right? First I take formal charge, some points related to this one. What is formal charge? It is the electronic charge present on each atom. Please go through your notes and observe the formal charge means oxygen atom present in a ozone. When you observe the formal charges or calculate the formal charges of oxygen atoms present in a ozone molecule, one of the oxygen atom contain +1 charge, another one -1 charge, and another one also -1 charge. Yes, remember the formal charge concept also. And another concept, students, that is Fuzzen's rule. Fuzzen's rule. As in the notes I given 2 points related to the Fuzzen's rule. Remember, smaller the size of cation and greater the size of anion, right? Smaller the size of cation, greater the size of anion, then higher in the covalent character in ionic compounds. Please go through these points. And another one point, higher the charge on cation, greater the covalent character in ionic compounds. Greater the polarizing power of cation, greater the polarizability of anion, more will be the covalent character. As if you know more about these chemical bonding concepts, please go through my YouTube channel and search the chemical bonding chapter videos, and remember all the important concepts comes under chemical bonding. Okay, students, in the next video we solve some multiple choice questions which are provided in your material. Okay, thank you, students.